Okay, so for our next problem, it says determine the mean, standard deviation, and 5-number summary for each data set, round to the nearest 10th if necessary. So like I said in the last video, I'm going to be using my calculator for this, which is why I already preset up my calculator so you wouldn't have to watch me type in numbers. But what we're going to do on our calculator, we're going to hit some buttons you've probably never hit before. But because we're in our statistics unit, it hopefully makes some logical sense that you're going to click on this stat button. And you are going to go to edit. So I've already typed in numbers for this problem and the next problem, so you don't have to watch me. But your screen should hopefully be blank. If it's not blank, you just scroll up to like L3 and click clear. And then it would have cleared everything typed into L3. I'm obviously not going to clear L1 and L2 because I just spent time typing in those numbers for us. So you're going to go through L1 and type in all the numbers for your problem into L1. Once you do that, you can hit second mode and that quits you out of that screen. So if you want your 5-number summary, your mean, standard deviation, and then the 5-number summary, there is a couple buttons on your calculator that do that for you. So go ahead again and click, I think it's VARs. No, it's not. I'm sorry. It is Stat Calc. There we go, Stat Calc. So in case you missed that, click on Stat and scroll over one to calc. I got a little confused because I know it was one variable stats and I didn't know if it was VARs. Okay, so we're gonna do one variable statistics because there's only one variable we're looking at here. And I am doing problem number 1 over here on our screen, and I typed that data into list 1 on my calculator. So I don't need to change anything. I can just click calculate, and it's going to give me all of these things. Now you need to know what some of these symbols mean. So X with a line on top of it, that is your mean. So our mean of this data set is 93.27. So moving over here, our mean, 93.27. Our standard deviation is, now they give us 2. They give us our S of X, which is our sample standard deviation, and then they give us sigma of X, and that's our population standard deviation. Unless they specifically tell you you're looking at your population, we're going to use our sample standard deviation. So our sample standard deviation is S of X, 7.71. And then our 5-number summary. So if you notice on your calculator, there's a little arrow right here, so you can scroll down and get more numbers. So the minimum number here is 79. Q1 here is 87. That's our first quartile. Median is 97. Q3 was 99. And the maximum is 102. So that is an incredibly quick way to do every calculation we did on this table above by hand when you have larger numbers and they're harder to calculate. And also, using your calculator to find standard deviation is significantly easier. I didn't even show you the standard deviation formula because it is somewhat complex. Okay, so number 2, it says describe the shape of the distribution and determine which measures of center and spread best represent the data. In my opinion, it's very, very, very hard to figure out what in the world is going on if this data, like, we have no idea what it looks like, right? So one thing I recommend doing is, if you notice too, when I went to my list, I already had these numbers typed into my L2. So if I type those numbers into my L2, oh, I hit a different thing. But if I type those numbers into my list too, then when I go to calculate one variable statistics, I would like it to calculate from L2, not L1. So I'm going to click second list and grab L2. So I want to look at L2 and calculate my 5-number summary for L2 because that's going to help me figure out what this might look like. So for L2, the mean is, it was like 1,243? Yeah, 0.79. 1,243.79, so that's our mean. Our median, if I scroll down, 1,254.5. 1,254.5. So without looking at anything else, we know that our median is greater than our mean. So think about above, when our median is greater than our mean, median greater than mean, that's going to be a distribution that is skewed left. So we can know from just a couple bits of information from that summary on our calculator that this is skewed left. And because it's skewed left, we would want to use the median as our measure of center. Okay, part 3. What would you expect the shape of a histogram showing the grades on a test to be? This will obviously depend on whether or not the class thought that the test was easy. So in my experience as an educator, I typically see, or I would hope to see, instead of it being like a bell curve, like a symmetric bell curve where the mode was a C, what I love to see is a bell curve that looks like this, where maybe this is about a B or an A, and there's only a couple people that got lower grades, like D's and F's. So a graph that looks like this would be skewed left. So that's what we hope to see. It's hard to estimate what it would look like if we don't know anything about the test, but that's what, as a teacher, I hope my data looks like. I hope that my data is skewed left, with most students getting A's or B's on the test and only a couple students not doing so well. Describe the shape and the distribution of a set of data where the median and the mean are the same. So when our median and mean are the same, that's a normal or a symmetric distribution. How would the median and mean compare if the data were skewed left? Well, again, we have these lovely visuals up here. So if the data is skewed left, then the mean is less than the median. So part 2, you could say mean less than median.